please remove value that you know that won't be used anymore, right? So the good practice in computer is just to complete like a very light, very clean your memory, right? Also your CPU, right? And this is the way as Swift recommend to use. So while the application is running, you are occupating that value. So of course we can print it and says and see if we have its values like even the person. I think that we are going to use something that later I will going to explain like this. Yeah, but don't worry. I think that yeah, it's work right. So we have the name, so we can says like this. We can says mm, we can says like this. We can says um this is the name of the tenants on the apartment. Uh-huh. Apartment in, we can say tenants in apartment in, right, in the address name, and we says address, right? Address is in that specific name in New York, right? So we of course we can have another name and we can rename it. So uh, we can also have what else? Uh, A2, I don't know, Boston. We can say Boston. The other person, name person could be like Peter. Just to show you, you know, the how it's work, right? Just you can put the name of course that you want or that you right. So you have here the name, right? Just to A2 and A2, right? Yeah. So you have the this thing. So that value, the name of the tenants in on the apartment, uh, in New York is John. You can put the words that you said, but we are just like a clean. But the good practice here it is that follow. So you have to says John, please free. Peter, please release this memory, these references. Please release the memory. This right. Yeah. That's cannot be no type, right? Nil. We can yeah we can put like this. We can says optionals and we can says functional. Yeah. Later I'm going to explain it's yeah we need to specify here something that it is like forcing like this. I don't know if it's missing something. Let's see if it's missing this one. Just very quickly to explain you and not confuse you in anything. Yeah, it says that can be unwrapped value. Yeah, just very quickly to check what's going on here. Sorry for the sorry for these things just to check. Yeah, it cannot be assigned person. Neil cannot be assigned as a person, right? Because let's see, name can be return name. Just to make sure. Yeah, I'm going to just to check. It says cannot be nil. Nil cannot be assigned. Okay, very quickly just to check what's going on here. Yeah. Okay. Okay. It says cannot be nil to person type. Right. Right. So here is the point. The point is that we need to remove the references, right? it is in that specific way. We need to remove references and we need to put values, for a specific reason. So we have nils cannot be assigned to type like a person, right? Yep. And says like right person jump, put that value and instantiate. I think that is not the point here. It just says nil person. We're of course using it. They need is use it. Yeah. Let's see. Let's see very quickly. Yeah. So if we have this point, it's just that later we were talking about more about it, but just to keep the idea regarding on it, right? So if we put here the initialize and we says, hey, please the initialize it, we already initialize it, right? And says give me the no here, I mean here, just to check very quickly what could be wrong here. uh, it is another point here, just to see very quickly. Yeah. Okay. We were talking later, we were talking about this topic, but just to it was just to it was it yeah it was to cannot assigned. Yeah, later we were explaining, but that's the point. That's the way as we and also Swift recommend to release the memory. Just remember that. So we have a class is more complex than struct for that reason, and a long answer of this is because the class have more complex copy behavior, and also several copies of a class could exist on the program. And on the point of the same underlying instance, this means that it's very hard to tell when a class instance has been destroyed. And the initialize tells to the user to the Swift when a class instance is destroyed, right? For structs, that's easy to figure out as structs is gone when whatever owns it's no longer around. So remember that structs don't need the initialize because you don't copy, by the data, right? So you are not using the memory references. That's the point. So don't worry. We were later explaining. Uh, so we have and remember also that we have this value here as we were talking about later presently. The actor, need to specify. This is a very quickly reminder. Let's talk about automatic references counter. The automatic references counter, like this, is is a way to keep track of of every single instance that class that was created, and how Swift know when the call the initialize. Every time copy class instance made in architecture's references counted at one references. Each time of every time copy that instance is destroyed, also subtract one from references count, right? Because it's when a reference counter hits zero, the automatic references counter be sure that nothing is there, right? And of course it's empty. So let's continue here that we have our references, and we says that we have, yeah, just to see very quickly if we can find our issue here, just to make sure that yeah, that was the point. That was the yeah, there we go. It was just missing, just going back very quickly to our point. So remember that we put here Peter, and says Peter, you are a person, but optionals. We will talk later about optionals. So